true, because you can remember, okay, I divided by negative, I guess.
Hold up.
Okay, 2.6,
I'm talking to you right now.
stop. Solving equations using multiplication or division. So yesterday we talked about solving equations when you use addition or subtraction, and it's a little bit more confusing because you have to be able to visualize the negatives. But when you're doing multiplication and division, it's pretty simple rules, right? If it's two negatives, then it's a positive, and there's one negative in there, it comes out negative. Whether you're multiplying or you're dividing. Okay, so it says the division property of equality, we have that going on today. Just like we had the multiplication, or just like we had the addition property of equality, and we had the subtraction property of equality yesterday, right? So the division property of equality says dividing each side of an equation by the same non-zero number produces an equivalent equation. Dividing each side of an equation by the same non-zero creates an equivalent equation. And then you have a, that's the division property of equality. And so then you have the multiplication property of equality. What do you think that one says?
When you multiply both sides of the equation, you'll get a equivalent.
Yeah, for the most part, it says the same thing. It says multiplying each side of an equation by the same non-zero number produces an equivalent equation. The opposite of division, yes. Multiplying each side of an equation by the same non-zero creates an equivalent equation. Okay, so you have the division property of equality and the multiplication property of equality. You have the subtraction property of equality and the addition property of equality. Okay? So, with that being said, you then get problems that say, solve this. Solve. Negative 6x equals 48. How do I solve negative 6x equals 48?
Oh.
Okay, Josh, what?
You will bring the negative 6x, or you will,
What's happening here with negative 6 and x? What are they doing? They're being what together? Multiplied. So to get rid of multiplication, you use division. So I'm going to divide everything by negative 6. So I get x equals what? What is 48 divided by negative 6? Negative 8. Yes, because if I divide, if I only have one negative, I'm going to get a negative, okay? So, division property says negative 6x equals 48. If I divide both sides by negative 6, I get x equals negative 8. This is the work you need to show me. Okay? Then, remember, we can always check our solution. Only if it tells you you have to check it. Okay? So if I go to check my solution, that means I'm taking negative 6, I'm plugging in a negative 8 to that x, and I'm seeing if it equals 48. What is a negative times a negative? And 6 times 8 is?
48.
So I have positive 48 equals positive 48. That is correct. Okay, so I checked my solution that way. Now, what happens if I want to solve something that looks like this? W over 7 equals 9. Okay? What am I going to do there, Carter?
You're going to multiply 7 through everything.
I'm going to multiply both sides by 7 over 1, right? Okay? Because I want the W to stay, so I don't want to multiply it by 7 over W, because that would cancel everything and wouldn't work. So I want to multiply this side by 7 over 1, and I want to multiply this side by 7 over 1. So here, the 7's cancel, leaving me with W over 1, which is just
W.
W. And then here, 9 times 7 is
63.
And that is how I solve using the multiplication property of equality. So if you have a fraction, you want to flip and multiply. Does that make sense? A fraction, I flip and multiply, okay? How would I solve this?
You would multiply 7 times.
Oh, you want me to plug it back in? Is that what you're saying? So if I want to, check, then I'm going to say 7 over. Nope, I'm not going to say 7. I lied. I'm going to say 63 over 7 equals 9. 63 divided by 7 is, and 9 equals 9. So that's how you check it. What happens? I'm going to just throw a bunch up here that you're going to solve, and then we're going to do a word problem, and we're done today because it's that simple. Okay? So let's solve this one. Someone besides Carter and Josh, because they've already helped me out this morning, tell me how to solve negative 60 equals negative 5a. How would I solve that one, Kate? Yeah, well, yes. Okay, reverse how you said that. Take negative 60 and divide it by negative 5, not 5 divided by 16. Okay, so 60 divided by 5. And I have a negative divided by a negative, so what is my answer going to be? Positive. And what's 60 divided by 5? 12. So I get 12 equals A. Okay? Who can tell me how to do this one? Let's try. Negative 8 equals B over 8. Negative 8 equals B over 8. E, how do I do that? Okay, multiply both sides by 8 over 1. I'm going to move my B so that I have room. Okay, and over here, this cancels, leaving me with B. And this gives me what? 8 times negative 8 is?
64.
Negative 64. Negative 64. So when I have one negative, I'm getting a negative. When I have two negatives, I'm getting a positive. Okay, positive. Okay, what about this? Y over 2 equals 13.
I know. You would do 2 or over 1.
Okay, so multiply both sides by 2 over 1. I keep not leaving myself room because I'm crazy.
And
Multiply both sides by 2 over 1, right?
1 times y.
Okay, so you get y equals 13 times
26.
26. Okay, and one more. Let's do, just picking random stuff. Let's do 2x equals 18. How do I solve that? Okay, Jason, what?
You would do divide by 2.
Yeah, divide both sides by 2, and you get x equals what? 9. Okay, so does this seem easier today?
Oh, heck yeah.
Oh, heck yeah. Heck yeah, because we're getting real answers, and we like getting real answers. We don't like just simplifying. You people that want answers. Okay.
It's a human mindset.
So let's talk about word problem. Let's try a word problem. Okay, it says on January 4th, 2003, the SOHO spacecraft, okay, detected solar wind traveling at about 2 million kilometers per hour. 2 million kilometers per hour. That's crazy. The sun is about 150 million kilometers from Earth. About how long did it take the solar wind to reach Earth?
I think I
So what are we looking for? Are we looking for a time, a distance? What are we looking for?
Distance.
A distance. You're right. We're looking for a distance. Do you guys know what the distance formula? Not the distance formula like the square root of, but distance can equal
Well, speed times wall.
Speed times Speed times distance times.
Are you guys taking this from physics class?
Yes. No.
Or from
Yeah,
what is that class you have with Mr. Burkett?
Oh, technology.
Oh yeah. So distance equals
Somebody
Okay,
says
the-
velocity.
Speed times velocity.
the most basic formula is distance equals rate times time. Rate times time. Okay? So distance equals rate times time.
Rate times
I know.
Yeah.
RT.
I
Rate
forgot about that.
times time. I know, that's crazy, right? Okay, so distance equals rate times time. And our problem says that the SOHO spacecraft detected solar wind traveling at about 2 million kilometers per hour.
Well, 2 million kilometers would go under distance and per hour. So wouldn't it be? Oh no. Hey,
It says,
Mess it up.
let me finish. Okay, it says, it's detected wind travel at about 2 million kilometers per hour, and the sun is about 150 kilometers from Earth. So what is my distance?
Oh, 150 kilometers.
150 kilometers. 150, well, it was 150 million kilometers.
Yeah.
So that means I should have 6 more zeros, right? Okay, so I know that equals my distance. Now, it said that it travels at about 2 million kilometers per hour. So is that my rate or my time?
Time.
Ooh.
No,
It's your rate, because your rate is always something over something, right? Like, and this says 2 million kilometers per hour. So my rate is it's going to be like miles per hour or minutes per feet or something like that. Okay. So I have 2 million over here. Okay, and then that means that I am looking for my time because it says about how long did it take the solar wind to reach Earth. Okay, so that makes sense. So how do I solve that?
You would do.
You divide the distance.
I divide it by
Time.
Time.
no, I divide it
You
by
divide it by the rate.
the rate, which is 2 million. So what is 150 million divided by 2 million?
25 million.
That wait what?
75 million.
Wait, what?
No.
What?
Not
55
75
million.
million.
3.5
Stop!
million.
Hey, stop! Stop yelling!
What?
Stop yelling! Not 75 million because I'm dividing a million by a million. So it's not 75 million. It's simply 75. It's simply
Oh.
75. If you plug it in your calculator, when you are dividing something that's already in the millions by something in the millions, it's just going to come out to a simple answer. Okay? Just a simple little answer of 75. So your time is 75. Now, the question is, what unit was this in? It said kilometers per hour. So what is time in? Hours. So it takes 75 hours. How many days about is 75 hours? I'm asking a random question.
Around.
How many what?
How many days about is 75 hours?
Three.
Wait. 24, 48, 72. That's about 3.
Yeah, it's a little over 3 days. So it takes a little over 3 days for this to happen. Is that crazy or what? And yet that's like traveling at a super fast rate because think about how much of a distance it's traveling.
How many
Could
minutes?
Humans travel at that rate?
What?
Could humans travel